All right. Thank you, everybody, for joining. This is the December 2021. I can't believe it's December already. Installment of the Microsoft Data Platform Continuity Virtual Group. Thank you all for attending, either live or watching this on YouTube later on. I really appreciate you attending. Our speaker this month is Lee Markum. He's going to be presenting a session on modern SQL Server features that make life better. And I don't know about you, I'm really excited about the session because I'm all about making things better for all of us. So with that, I am going to go ahead and turn this over to Lee.
All right, thank you, David. I very appreciate it very much. So good afternoon, and I'm glad you guys could, everyone could join us. And again, just in case you're wondering if you're in the right place, we are going to be talking about making SQL Server or modern SQL Server features that will make your life better as a data professional. So first of all, I just want to thank the group for extending the invite. Very much appreciate being able to be here and present the information to everyone. So what problem are we going to solve today? Well, there are two things that will be addressed, or two problems. I want to show you, first of all, why you should upgrade. Some of you maybe have SQL Server that are pretty old. You like them because they're stable, there's lots of support, you don't have to think about it too much. And so you're kind of like, why upgrade to SQL Server 2017 or 19? Because I kind of like it where I'm at. So this presentation is for you. Secondly, some of you would really like to upgrade, but you have a person in your hierarchy who is putting the brakes on it, and you're not quite sure what's in there that you could use as a proposition feature to say we should upgrade because of this. So this presentation is also going to be for you, so you can talk to that person in your hierarchy who is not letting you upgrade. A little bit about me here on the slide. I've been in IT almost 14 years now, officially as a DBA. Started as a DBA back in 2014. So like most of us, I had a bit of a journey to get there. I was doing the work before I got the title, like a lot of people, and that's okay. That's how things work. I blog at leemarkum.com, and also weekly you can see me on Twitch at Ready Set Data. Feel free to email me at liam@leemarkum.com as well. And there'll be a contact slide at the end as well. So I want to set some expectations. I'm mostly trying to introduce features to you and do so in a way that highlights why it makes your life better as a data professional. All these categories that we're going to talk about, most of them could be full-length presentations in and of themselves. So I simply can't provide the kind of in-depth coverage of these features. We don't have time for that. I am only going to consider features from the database engine. And again, that's because I have a limited amount of time. I can't talk for 3 days. And so, and the other reason is, while I got my start with SQL Server in reporting services, I haven't done reporting services on a regular basis in years. So I want to stick with what I can confidently talk to you about. So just remember, there are a lot of features I could have chosen from. If your favorite feature or something you think should have been mentioned isn't in here, then bring it up at the end and we'll talk about it. Just realize I can't talk forever. I have to pick and choose some things. So agenda is, we're going to talk about features in the following categories. We're going to talk about performance changes in modern SQL Server that make your life better. We're going to look at some troubleshooting enhancements. There have been a few permissions changes that make creating permissions at a higher level easier. We're going to look at a few T-Sql changes that help you write less code, which means you can move on and get to other things quicker, saving you time. I'm sure your boss would be interested in that particular benefit. And then we're going to talk about high availability and disaster recovery in modern SQL Server. I am talking about just on-prem, by the way. So we're not going to be talking about Azure in this particular presentation. So how did I decide what I'm going to talk to you about? What SQL Server versions do I even talk about? What qualifies as a modern SQL Server version? So I have a favorite website, sqlserverupdates.com, and I go there quite frequently to figure out, okay, what's new, what patches are there, what's wrong with them. A lot of times the latest patch will have a strike through, and I know, hey, don't use that one. But in there, one of the features beyond what I've just described is there's a release cycle and their end dates for extended support. So SQL Server 2012 extended support ends in July of next year. So you just have less than a year of support there. So I wouldn't use that. Extended support for 2014 has a little more life. So primarily what I'm going to do is talk about features that appeared in SQL Server 2014 and forward. There'll be a couple of exceptions. Those exceptions will be there because the particular feature has continued to have enhancements since 2012 that makes it viable in future versions of SQL Server. So performance features, this is the first category of features that we're going to discuss. So things in modern SQL Server features that will make your life better in terms of performance. Intelligent query processing. So this is not a feature, a single feature. It's really a collection of new database engine features. And some of those began in 2014. And again, they've continued to be enhanced as SQL Server goes forward. And I'm sure I've already seen headlines, but haven't looked at those videos. But I know that intelligent query processing is an area that continues to grow even in SQL Server 2022 that hasn't been released to the public yet. I'm just going to talk about memory grant feedback, just to give you a taste of what it does, what the intelligent query processing feature or collection does. So memory grant feedback is really meant to help with scenarios when either too much or too little memory is requested for a particular query. So when a query needs to run, a request for memory is made. And once that's granted, then the SQL Server can run that particular query. A memory grant that's too small for a query can occur, and then that usually means SQL Server underestimated the rows that are going to come out of the query for whatever reason. And as a result, you often will get the spill to disk over on TempDB, which nobody likes because that hurts your performance. When SQL Server then sees that query again, it remembers by some black magic that, hey, I didn't give this query enough memory last time and we spilled a TempDB. I'm going to give it more memory so we can avoid the spill. And so from that perspective, intelligent query processing helps your performance without you doing anything. The same thing happens, the reverse is also true if it grants too much and it realizes, oh, I gave you, I'm going to make up some numbers. I gave you a gig and you only needed 200 meg. Well, the next time it sees that same query, it's going to dial it back. So that's a nice feature, I feel like, that just makes things better for you because it means you don't have to do anything and things just get better. I kind of like that option. So let's take a look next at lightweight query profiling. I feel like to understand this, we kind of need to talk a little bit about what came before it, the standard profiling infrastructure. So in previous versions of SQL Server, you could get, in a query plan, you could see row count information per operator, per thread in the standard profiling infrastructure. But the catch is that you had to capture the queries you wanted to know about ahead of time and then rerun them after turning on some things like set statistics profile or set statistics XML. So while then that long running query was manually executed, you could go over to another screen and run sys.dmexec query profiles and get some information about row estimates and how many rows had actually returned at that particular point in time. You could do this through capturing execution plans using the query post execution show plan event in an already running extended event session. However, the standard infrastructure, turned out to have a much higher impact on the performance than Microsoft really wanted. And so they came out with lightweight query profiling. A main difference between those two things is that in the lightweight query profiling doesn't capture, doesn't collect CPU information. The other significant difference is that, at least in SQL Server 2019, the lightweight, that's really a tongue twister apparently. The new feature, how about that, is on by default. So you don't have to capture something, then turn it on, then run again to see the information. It's always there, available to use while a query is currently executing on your system. So we're going to go ahead and do a demo of this feature that helps us answer the question. It's pretty common. Should I kill this query? This demo comes from code made available for Bob Ward's GitHub and goes along with his book, SQL Server 2019 Revealed. So here's the link to that GitHub. There's a lot of setup in here, and basically he just creates a copy of a table and then makes it big. So we're going to skip all of that because it takes several minutes to run that and get down to the good part that you came here to see. Again, if you wanted to recreate this, look up that link, that GitHub link, and you can recreate this for yourself. So he has a query that he said that he calls my smart SQL query.sql. Bob jokes when he talks about this that that's your first clue that it's not a very smart query. So I'm going to go ahead and get this running. And all it does is it sets up a join between the original table and this extended table or expanded table that he made. While that runs, you're going to come over here. And look at this part. So this uses the sys.dmexec query statistics XML we talked a little bit about. This is a new function in 2016. And you can see you have some CPU time and some logical reads. If you keep executing this, you can see the CPU time and the logical reads continues to go up. And this is a good clue that you have a query that is obviously chewing up a lot of resources and you need to figure out what do I need to do with this. And one thing I want to show you about this is you do get the show Plan XML. If you open that, you can see that there are numbers here that tell you about the number of rows returned already versus how many it expects. And in this case, you have this huge number. I have no idea what that is. It's a huge number. And it's only returned 5 million rows so far. So we're going to be here a while, folks, if I just let this run. Now, if I execute this again and I open this, then these numbers change. So the XML shows you the actual rows returned for each time you execute that query, which is handy. But what if you didn't have to open the XML all the time to see what was going on? So this is where sys.dmexec query profiles comes in. If you look at this, you get this estimated row count and the operator that is involved here and here. So table spool and the nested loops. And you can see the actual rows that have been returned so far. I don't have to open XML. I just have to execute this again, and it updates. And again, this is, I feel like, something that makes things easier for you. You don't have to keep opening XML, just hit execute. And you can see this is never going to finish. So this is a query that you probably should kill. So I'm going to go ahead and come back and just stop that execution. And move forward a little bit. This particular feature can be enabled in previous versions of SQL Server using a trace flag, that trace flag 7412 that you see there on the screen. And again, it's on by default in SQL Server 2019. So the next performance feature that we're going to talk about is Query Store. Now, Query Store solves the challenge of persisting performance data over time. Prior to this feature, there was the management data warehouse in SQL Server, and that feature can still be enabled. It's still there, but Query Store is superior to that in so many ways. It's easier to turn on. It has very little management needed compared to what I went through when I was just experimenting with management data warehouse. Doesn't mean that you shouldn't ever use management data warehouse. I'm just letting you know the kind of experience I had. I think you're going to have a better experience with Query Store. Outside of the management data warehouse, if you wanted to persist performance data, then you had to do something like a server-side trace collecting data, or extended event sessions capturing performance. And both of these methods, but particularly the server-side trace, has some significant overhead depending on what you're trying to capture, especially things like query plans, really expensive, and you really should not capture those in a server-side trace, or probably ever, since you have better options. If you're on one of those older SQL Server versions, this might be your only option. But again, that's why you're here, to figure out why you need to move up, to make things easier for you, things that will not cost or not cost SQL Server so much, not create that performance hit just when you're trying to troubleshoot and get some data. You can also do things like record output from Animated Mechanics SP Who is Active, or some of the first responder kit things that originated from Brent Ozar. I don't think any of these approaches gives you the kind of insight you're going to get from Query Store, though. It provides, all of the previous mentioned options are things that you'd have to manage on a regular basis, or put a fair amount of effort in just to set it up and keep it going. And I just went way past where I need to go. All right. So I feel like Query Store just frees you from having to create and manage your own monitoring process. And that alone can save you a lot of time and energy and frustration. And some places don't allow or don't have third-party monitoring. And so this is a great native feature that you can turn on and not have to try to bargain with your boss to buy a third-party tool. With respect to that, I've seen the question asked, okay, so if you have Query Store, should you buy a third-party tool? That depends on how much detailed perfmon data you want. For an example, Query Store is not going to capture that kind of information for you. They can go together. You can have Query Store and third-party monitoring. So just because you have that enabled doesn't mean third-party monitoring is out the window. They can work together. If you want, so in blog form, if you want an overview of Query Store, you can take a look at that link for my blog. And Aaron Salato gave a presentation on Query Store at the meetup that I co-organize, and it's out on YouTube at that link. And you can also just search St. Charles SQL Server Meetup, Aaron Salato, and you'll find that. So what's in there? What's in Query Store? You're going to get performance metrics, query runtime metrics from lots of different angles. And you're going to see weight stats information that gets collected in SQL Server 2017 and above. So you'll see categories like IO or parallelism or network, and you'll be able to drill into those categories of weights to see what queries generated those weights or experienced those weights. You're also going to see in SQL Server 2019 some custom capture policies to allow better control of what query store captures. If you have a very ad hoc workload, meaning either you, your users, or your applications, or all of you, are sending in queries that have literal strings connected to them, select these columns from here where name equals David, where name equals Lee, where name is Matt, then all of those create a separate entry in query store, and that can create a bit of a burden for the management. So there's some custom capture policies that give you more buttons, more levers, and that sort of thing to help control the nature of what query store actually will collect for you. Query store is a database level feature, so it's not an all or nothing thing for everything on the SQL Server instance. So if you want to just try it somewhere after you look at the ad hoc nature of your workload, you could try it at a single database or on a single database, turn it on and see what it collects for you. You get query plans and the related estimated performance metrics, the estimated plan. You can do things like detect regression. You can actually force plans. So in cases where you perhaps have a parameter sniffing issue happening, you could find a plan that works well most of the time and force that plan, while you then later, you and or the development team, whoever works these kinds of scenarios in your company, looks at the queries and then tries to actually solve the issue. Then you can come back and remove that force plan. There are quite a number of various reports that we're going to show you information graphically, which I really like visuals. And one of the new things for Query Store is trace flag 7745. So Query Store has a setting that says, I'm going to collect information for a maximum of X minutes and hold it in memory. Once I get to that limit, then I'm going to write it to disk. Well, it does that even when you do things like restart the SQL Server, or you have a failover for an availability group. Then SQL Server tries to write that information that it has stored in its memory to the disk before the restart happens or before the failover completes, which can delay your HA or DR solution. If you turn on trace flag 7745, that process is skipped. This means you're going to lose some query store data, but in my opinion, it's a fair trade-off. You probably don't care about that last 15 minutes more than you care about getting to a stable SQL Server. So I would just encourage you to look at that trace flag, think about your environment, and think about whether you want to go ahead and use that. I would encourage you to use it, but again, you have to make that decision for your own environment. So we're going to take a look at Query Store. So Query Store, again, it's the database level, and I'm going to come in to look at wide world importers, and you have this Query Store folder. So if this Query Store folder is not here, then Query Store is not enabled for that database. You drill in and you have a bunch of canned reports. I typically start with top resource consuming queries if I just want to see, okay, what's been hurting my SQL Server recently? So right click and run the report. It starts by giving you the last hour. If you want more, you can up in the upper right hand corner here, click the configure button. And here's where you get all those various options of ways to slice the data. It starts off by duration, but there are lots of options here. You see physical reads, logical writes, degree of parallelism. Once you set something on the left, then over here on the right, you can say based on, I want to see the average duration or the average CPU time or max. Here's where you can tell time intervals. So lots of options in here. I'm going to go back and do custom just because I want to go back a few days and I want to show you how it works. So you just get a drop-down calendar, point click, and you go back and you click apply. So I like the graphical nature because it's really easy to see what the problem is. The tall green bar. Let's start with that. If you hover over it, you have a query ID there. You can see the total duration for whatever this particular query is. You can see an execution count of 3 times. It has 1 plan. And you can see the query plan down here. This is the query that I ran earlier just to demonstrate the should we kill this query scenario. If you hover on the right side, you get these little blocks that represent plans. If you hover, then you can get the execution count. That one's not as interesting because it's only executed once, but I wanted to point out, let's look right here. So this is executed twice. So you have an average duration, that value that's in there, a min and a max. You can see over the course of 30, 300 executions, how many is in there? What's the average execution of this? And what's the max execution? So that could be important information. You can change this box if you're not into big bars like this. You can change it to view information in a grid format. And this can be interesting because you get to see the query right away. So maybe you're not interested in this one. Maybe you're looking for a specific query. And this is a nice way for you to be able to find that query. Let's look at query weight statistics. So this is the one that gives you categories of weights. Again, when you run a query, when you open up one of these reports, it defaults to the last hour. So whatever changes you made over here in configure is just for that report that you're looking at that time. I'm just going to back it up a little bit and maybe see if we can see something a little more interesting. Okay, so we have a network IO category here, and there's some average and min time. If I double click into this, which is your parallelism, actually it's single click, my mistake, then you can see the queries that are involved. There are 3 queries. These weights are almost negligible, but you can still see what they are if you just hover. And here you can see you have this has been executed 6 times. This is the query that's in Bob's demo that builds out the sales invoice extended table that he uses. And you get the average min-max information and total wait time in milliseconds. You can also change, so you have a wait category here. You can also change to average wait time, max wait time, etc. So within a particular report, you can change what shows up, how it slices the data for you. Another interesting thing is for these particular scenarios where you have multiple plans like these, if you shift and hold down where you can select 2, then you can, I have to get close because my eyes don't work like they used to. This icon says compare the plans for the selected queries. So if you click this button, now you can see what's different between these particular query executions. In this case, the shape is the same. You can kind of eyeball that pretty easily. I don't have an example ready where the shape is different, but that would be obvious once you use this feature in that scenario. But what is different is you have these different amounts of values for things like the cache plan size, compile memory, and these sorts of things. So you can see, even though the shape of the plan, what the operators were the same, there were some differences in values that SQL Server used when it actually ran that particular execution. So that's Query Store. So the next category in modern SQL Server features that make your life better as a data professional is going to be troubleshooting features. So there are some enhancements that help you troubleshoot things that are going to save you time. I'm sure that if we could all have seen this particular enhancement together, the aliens would have been like, what is happening on Earth? Because we've all, as data professionals, wished for this for decades, maybe. The dreaded string or binary data would be truncated error. It's just really not very helpful. It just says, I'm broken. Good luck with that. And it doesn't give you enough information. So there's a little code on the screen that just helps you recreate this. When you run into this as a data professional, at worst, it's on a SQL agent job you've never touched, that touches tables you've never seen, that's involved in some kind of SSIS process that you don't know anything about. And makes it really hard for you to go spelunking through the data then to try to figure out, okay, why is this broken? Obviously, I can see that SQL Server tried to take some data that was too big and put it into a hole that was too small. But that's all you know. And so you get a better message with SQL Server 2019 for both truncation warnings. It speeds up your troubleshooting because it tells you exactly where the problem is. It tells you the database, the table, and the column name that was truncated. That's useful. Unlike the I'm broken message that you got before. So you can turn this on. If you're not on 2019, you can turn this on in SQL Server 2017 using trace flag 460. Again, if you're on SQL Server 2019 and the compatibility level of your databases is set to 150, which is SQL Server 2019, then you just get this fabulous better error message by default. So these are great reasons for you to move up to something newer. I would say, especially if you have a lot of agent jobs, you have a lot of SSIS stuff that runs, this could save you a lot of time and or your team trying to figure out how to fix something. So great feature. Now, the next troubleshooting feature that we're going to look at is temporal tables or system version tables. And I like this feature because I think it's a simpler change tracking and data recovery. I'm not saying it replaces the change tracking feature in SQL Server. I'm saying if you're in love with triggers for whatever reason, you should really check out temporal tables. So it's just composed of a normal, what I just call a normal table, or your, so I refer to it as your source table, and a history table. So when you turn this feature on, this history table is created, and that table keeps a complete record of updates and deletes by tracking versions of rows based on a particular time period. And that time range start and time range end values, they represent the time range during which that particular record was valid in your source table. Well, why would you want to do this? What use can you get out of it? So you can use things like temporal tables for things like tracking price changes for products over time, and then use the history table to analyze trends. And you can also then recover versions of rows that existed before somebody had an accidental change that they made. This feature is also just useful for auditing changes, in a table. What happened to this data and when? You don't get who with temporal tables. There is a link to an MS SQL tips there where Ann Bertrand wrote an article about how to combine temporal tables with other things that will get you the who, in case you're really interested in slapping hands. You can check out that as a possibility to help you know who to go to. Your temporal table has to have a primary key. Like I mentioned before, it can be used to replace triggers and can help you answer, what happened to data and when. Let me tell you a story about why I love this feature. I was at a previous location, a previous employer. There was lots of Microsoft Access. Business users loved it, and they would connect to SQL Server, pull down data, massage it, and make reports or whatever it is that they were doing. Unfortunately, they would also use Microsoft Access as a front end to maintain the data in SQL Server. And that was the request that I got. Please allow so-and-so person to have access to this data so that we can update product information. So I went to this person's desk, and because I wanted to understand the process, what exactly am I allowing here? He pulls up Microsoft Access, and he's showing me what he's doing. And I'm kind of shaking in my boots already, because it's just Access. And as he types, he's changing data with no constraints, nothing telling him, hey, you can't do that because of XYZ. There's no application enforcing any kind of rules. It's just him free in the database. So as I'm observing this, to my right, up walks a coworker. The two of them start talking to each other. The coworker looks at the screen and he says, hey, coworker A, that change you just made, that's wrong. And I'm standing beside or behind the two of them, and I'm thinking, yeah, this is why I didn't want to give you this ability. So coworker A, types and fixes it. Well, the lucky thing is it's just like 1 or 2 rows. But what if it was 1 or 2 million rows? Now we have a problem, and you're going to be calling me anyway because your data is messed up. So I put this feature in place, this temporal tables, so that when mistakes happened, because I knew they would, because they just did, and they called me and said, we did something between 1 and 3 yesterday, and it's broken, I could get the records back to what they looked like between 1 and 3 yesterday. And I could find those records and put them back in the table. So let's take a look at temporal tables. So I'm going to be over here in AdventureWorks. This is obviously an old version, as you can tell by how it's named. I'm just going to create a backup of the table, and I do this just because that means I don't have to keep restoring AdventureWorks. I can just toy with a backup. This takes almost no time to do what it needs to. 504 rows. So we have that many rows in a backup of the table. So the temporal or source or original table has to have a primary key. So we're going to go ahead and do that. Trying to make this wider so you can actually see what's happening a little better. So some data that might be of interest. Let's say that you want to raise the prices of everything in your accessories category by 10% because you're not making enough money, or you're greedy, or whatever. So as this rolls downhill and you get the request as a developer, as a good developer or database administrator or any other kind of data professional, you're going to first write a query to make sure that you can actually calculate 10% correctly, right? I hope you're doing that. So here is a query that gives you that information. So here is product name, product number, here's the list price, and here's the new list price. You scroll through and like, yeah, that looks right. On something more complex, you might even give it to someone else and ask them if it looks right before you proceed to the next part. So we're going to turn on system versioning on an existing table. Now you can create system version tables from scratch from the very beginning. That's not what I'm showing you here. I'm just letting you know that you can do that. So it is often recommended to create a schema to hold the history table. So I'm going to go ahead or the history tables. So I'm going to go ahead and do that. It's not required, but it's often recommended. This next part here is actually I'm going to walk you through a little bit about what it's going to do. You're going to add a sysstart time and sysend time column to your table. They don't have to be called that. These are just the columns that you need. So the temporal table, the history table can use that as a way to track versions of records at this time, at a start time, and at an end time. You are going to use this default. You do have to, so this end time will be specified as this value. Then you say period for system time, and here's your end or your start and end time. I'm going to run that. Now, I still don't have the system version table. All I've done is change my source table so that I can turn on system versioning. So I'm going to do that now. Alter table, set system versioning equals on, history table, and here I have a name for my table. You don't have to name the table here. I would strongly encourage you to do that though. Otherwise, you're going to get a table like history.prodxyz1249 underscore whatever, and it won't make any sense to you or anyone else who looks at it later. So I would encourage you to name the table. So we're going to turn that on. And as a good magician, I'm actually going to fix something that's not really broken, but best practice. Here's my semicolon. I'm just going to show you that there's nothing up my sleeve. There's nothing in this table, which you would expect. So we're going to go ahead and run the update. So I took the select that we had earlier and I converted it to an update. I'm just going to go ahead and run this because I've run it a million times. I know we're going to get the 29 rows. Now, I would encourage you maybe to just run the begin tran part and actually make sure you get 29 rows and then commit it. I don't know, it's up to you. But that's one way to make sure that you're not about to do something that is unexpected. So one method to figure out, okay, what's the value here is this query. You can actually do a join between those tables. It's not the way that the documents show you how to do it, but you can do it this way. So you have the product name, the current list price and what it used to be, and here's the start time and end time for this row. So between this time and this time, the price for this product used to be $34.99. So this column represents the way data used to be, the way things used to be for this particular time frame. You can just use, in this case, because I've only made one change, you could just query the product back up the history table by itself. And here are the 29 rows. And certainly that's valid no matter how many changes are in there. That would work fine. You would just have to watch for the sys start time and sys end time. As those change, then you have a different set of changes. You can use for system time all. And this essentially does a union between the source table and the history table. And in this case, I'm going to get 533 rows back. The 504 rows that were in there when I created the table, plus the 29 that I changed. And this reminds me of something that I wanted to come back and tell you about the syntax. So in this part of the syntax, back where we're going to change the table to get us ready to turn it on, I have generated as always as row start hidden on both of these. So what that does is when you do select star from the product backup table, you don't get sys start time and sys end time from your source. So I know that we all know we shouldn't be using select star. I also know that we use it. So just keep in mind that you can hide the columns that you're adding to your source table so select star doesn't blow up. So I forgot to mention that. So an interesting thing here that I want to tell you about is you're going to say to me, yeah, that's great, but what if I want to change my table after I have system versioning already on? You can do that, and many of these changes you can make without doing anything else. Like there's nothing extra to do. So you can change a column, you can change the data type. And again, just to show you that there's nothing on my sleeve, we're going to take a look here. So the production.product, oh, I'm in purchasing. No wonder what I'm looking for isn't there. Oh, I'm also in wide world importers. Here we go. So the name column here is 50 by default. So when I change this, not only you'll see is the column in my primary table or my source table going to change to 100, but the history table is also updated. So there's nothing special. You don't have to like run 2 updates or 2 alters or that sort of thing. You can also do this if you want to add a column. Let me get this over here. We can see what I'm doing. This also works perfectly fine. I am going to run through a little bit of cleanup here just for my own purposes, but also because it helps me, it reminds me to explain something to you. As I said, you can make some changes to temporal system version tables, and it's essentially free, like there's no extra work. Some things you do actually have to turn off the system versioning in order to do. I don't have a list of those things for you. I'm just letting you know that you can't just do anything and everything to a system version table where the system versioning is on. So you do have to sometimes turn it off, make your changes, and then turn it back on. That does give you a slight risk of you're going to miss some changes, maybe. So just be aware that that's the case. So you do that right here with alter table, your table name, and then set system versioning equals off. So you would do this, make your change, and then run this again, but say set system versioning equals on, and then you're back in business for capturing changes. All right, so that's temporal tables. So the next category that we're going to look at is the performance enhancement features that you're going to find in modern SQL Server. Permission enhancements, things like granting select permissions to groups of people at the server level can be done. You can also give people access to monitor your system using DMVs without granting them access to the actual underlying databases. So people can monitor, but they can't access the data inside the databases on your SQL instance. And you can do that with this connect any database. You can use select all user securables with connect any database to, as again, give access to groups of people who maybe they're SSRS folks or just ad hoc SQL report writers. Maybe they're not even using SSRS, but they're connecting to your systems because they need to write reports. You can, instead of having to manage more granular permissions at a database level, database by database, combine these kinds of permissions to grant, read, or select to large groups of people. That can be a little scary. I'm just saying that there are use cases for this feature. The next category of modern SQL Server features that's really going to make your life better from a data or as a data professional, it's going to be T-Sql Enhancements. There have been loads of changes since what I'm calling modern SQL servers have come into existence. So again, this is another area where I can't possibly talk to you about all the changes that are out there, or even more than 10% of them. Just know that there are T-Sql enhancements that are going to make your life better. It's going to help you take less time to write code. And I'm sure that your bosses would be fantastic to hear that. What data professional, if we let you upgrade to SQL Server 2017, you can get features written faster? That sounds interesting. Tell me about that. So I'm going to tell you about it with a small sliver of what's available to you. So their drop if exists. So drop if exists really simplifies scenarios where you need to see if an object is there before you drop it so that you can then create it. This can be useful in situations where you're like deploying new SQL objects via scripting. This syntax works for tables. It works for table constraints. You could do this with table columns. You could do it with procedures and triggers and potentially other things. I just know that it works with that. A variation on this drop if exists is creator alter that you can do with things, again, like stored procedures. And in this case, when you combine creator alter with stored procedure name with the feature like query store, you're actually saving yourself some headache. Because if you drop a procedure and then recreate it, not only are you going to have to potentially, I've had to restore permissions because you got rid of a procedure and then you added it back. The object ID changes, which means that in query store, the next time that procedure runs, you get another entry in query store for that stored procedure. And maybe all you did was change some code, 3 lines of code in the middle, but now you've got multiple entries tracking what it thinks are different stored procedures. And internally they are, but from a name perspective, it's the same thing. And now you're going to see 2 entries in query store because you dropped it and created it. If you use creator alter, that won't be a problem. You can also do things to tables while the table stays online. So feature has a fair amount of restrictions, but, and I did play with it some. It does seem like there's some general usefulness to the syntax change. You can do things like change data types, change column length or precision. You can change sparseness, collation, and all of these kinds of things while the table remains online for you. So that helps with having to ask for a maintenance window, because we all know that's a pain in the butt. And it keeps your stuff just running while you're doing the things that you need to do as a data professional to keep things running smoothly. You can also do things like inline specifications for indexes. So when you go to create a table and you know, because you understand how this data is going to be used once it's in there, you know that certain indexes, certain columns are going to be used a lot. You can actually create that index right in there in line while you're making the table. And it saves you time because there's less to write. You don't have to alter the table after the fact or do other things in the syntax. And I'm going to show you all these things, or most of them, in just a minute. There are new string functions that we'll see in there, like concat with separator, translate, trim. So with trim, no more nesting left trim or L trim and right trim together to get rid of spaces before and after. You just use trim and you're done. Makes things easier to read. And again, it's less time writing code for you and less hurting eyeballs trying to figure out the nesting. And then you have things like within group and string ag. So let's take a look at some of these T-Sql enhancements. I'm going to switch over to my DBA utility database. So here, I'm going to create a standard table. So now if I have maybe forgotten I did this because that was 2 days ago, and I've had to do a whole bunch of break fix stuff, and I go to recreate that table because, again, I forgot, I'm going to get this. Hey, that's already there. If you do this when you're deploying, your deployment's going to break. A previous method for checking out whether that object is there is here on the screen. You've got 7 lines of code. That's not much. I mean, there's nothing hard to understand here, but it's a lot of typing. What if you could do this in 1 line? What if you could just do this? Drop table if exists, and then table name. That'd be pretty sweet. Boom, you're done. You can also do things like drop the procedure if it exists. Again, I just told you not to do this. I'm just showing you that you can. I'm sure there could be some scenarios where you might want to do that. So how does create or alter work in this case? So we have this code here, and I'm just going to say create or alter proc and give it a name. Inside, I'm just saying select top 5 from this table. That works perfectly. When I execute this, I get back 5 rows, which is what I expect. It's a little hard to see because I've scrunched the screen down a little bit. So I've got 5 rows back. Now, if I come in here and I run this, what SQL Server is going to do is it sees that it's already there. So it's just going to change the definition of what's inside. And that's it. So there's no need to run a lengthy query to see if this procedure is there already, and then change it if it is, or make it if it's not. You just write create or alter proc name, and you're done with that particular part. When you execute the procedure, you get back down here in the lower right. I've got 50 rows back now. You're done. You can move on. So inline specifications for indexes. I really like this. Started using it recently since I discovered this summer that it was there. I notice I'm using my drop table if exists. I'm going to make a filtered index. And in my table definition here, I'm just saying index, my name, the column, and where column 1 greater than 0. so it's filtered. So you can make filtered indexes inline without having to come down here and type in, create index ix1 on dbo.t1, blah, 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 blah. Who wants that when you can just do this? So you can do multi-column indexes, index non-clustered C1, C2. This works beautifully. I can have a multi-column unique index. So I already gave it away because I scrolled up, but if I hadn't given it away already, I had wondered, because I didn't see this example, can I do this to make a unique clustered index? So I typed it all out and just see, does that work? And yes, it does. Now, obviously, this doesn't create something that the SQL Server recognizes as a primary key, but you use unique indexes, unique non-clustered, and you could make a unique clustered on index somewhere as well using this inline specification. So we'll take a look at concat and concat with separator next. I realize that you can't see that entire link, but if you, I do have, now you can. If you just look at leemarkum.com and do a little search, you can see a whole blog post on how this works. I'm going to show it to you. So in the olden days, you would do a concat like this. Column name plus whatever separator you wanted, plus column name, just repeat ad nauseum. There are some problems with this, not to mention beyond the fact that that's a lot of typing. I'm going to show you why you should use concat instead. So down here with concat, you're just doing concat and then your left and right paren, columns, and your separator. So there's no plus sign. You're reducing all the typing between plus, space, and typing all this out. You're also getting some functionality differences. So notice in the top, we have a whole bunch of nulls. We only get one value that's even usable. Well, that's not really very helpful. So now I'm guessing, to make the top part work, I've got to do something with these nulls. I've got to coalesce or use a case or something to try to clean up the data. Well, if you use concat, you don't have to worry about that. Even though I have nulls down here, I still have data here. Concat just gives you the data that's there. It says I have some data. It's not all empty or null or unknown. So I'm going to show you what I have. I think that's a lot better. So that's a really nice feature that just makes your life better. Can you get this data? Can you get all these names using an old, the older style? Yeah, but it's more work. Here's what concat with separator looks like. It's a little less typing than even concat because you're only doing the separator once at the very beginning. And it works the same way as concat in terms of what it does with nulls. You still get back the data that is there instead of getting back nothing when only one column is null. All right, so now we're going to talk about high availability and disaster recovery features in modern versions of SQL Server that are going to make your life better. And on this more complex topic, I'll say something I wanted to say at the beginning and kind of did. I'm just demoing this stuff to you. Please do not take this information and just go do it in production. You need to test it, make sure you understand it, And then especially with something like the temporal tables or what I'm about to talk about next, there are a lot of things to consider and learn. I'm just reminding you, I'm introducing topics here. So what is high availability? When I say that, what are we even talking about? High availability refers to being certain that your application is going to be accessible and working properly as much as possible. It has to do with maintaining uptime for your SQL Server so that you're maintaining uptime with everything that touches your SQL Server. And often I have had pushback about doing this in environments because the rest of the environment, the rest of the infrastructure wasn't highly available. And my pushback to that is, just because you're not doing it on your side, that means I shouldn't on my side. We should all be in the same bad bucket together. How about we use this as a starting point to say we should be highly available? So examples of things that are part of high availability planning might be network path redundancy to storage, having multiple computers up and running to handle workload, for example, like multiple web servers behind a load balancer. You also might have, redundant copies of data for a SQL Server. And for SQL Server, there are methods to keep entire instances available, like SQL Server Failover cluster instances, and there are methods that keep individual databases or collections of databases online, like always-on availability groups. So when we say, so that was high availability. What's disaster recovery? How are those two things different? Well, disaster recovery plan is used to keep your applications up and running in the event of the loss of your primary data center. So let's say your data center is in that building in the picture. I'm just going to clue you in. You have a disaster recovery problem right now. If your data is in there, you can't get to it. It's probably wet. It's probably off because it's wet. So you need to plan for this sort of thing. And disaster planning allows for redundancy of your system in a remote location. And I started to say that's all disaster recovery planning is. That's a summary. Disaster recovery planning is deep and nuanced, but at the highest level, that's disaster recovery. So availability groups. This is the first thing we're going to talk about in this category of modern SQL Server features that make life better. If you're not familiar with availability groups, you can get more information at the two links there at the top right of the slide. That first one is Microsoft Docs. It just answers the question, what is it? What is this thing called an always-on availability group? Why do I want it? What's it do? And we're going to talk a little bit about that. If you already have availability groups and you're struggling with them, you're A, not alone, B, keep working with it. But there's a link there that on my blog for a post. My availability group database isn't synchronizing, and I give you some troubleshooting tips on things that I've found to be problems and that I look at first when things aren't working like they're supposed to. So the always-on availability group feature is built on Windows failover clustering, and a Windows cluster is a logical group of Windows machines that are working together to support an application or one or more applications. In the depiction that you see on the slide, we have multiple Windows machines together in an availability group. And these databases that you see down here where it says primary replica on the left, and then on the right, you have 4 secondaries. So these databases are in an availability group or a collection of databases, and they will often have an availability group listener, which is not depicted. I took this from this screenshot from Microsoft Docs, and there's no listener here, even though it's a recommended best practice. I don't understand why the listener isn't there, but the listener is just a name. It's a connection name for your applications. Functionally, it's the same thing as the virtual network name in a failover cluster instance. So rather than your application needing to know or be switched back and forth individual nodes, your name or your application just needs to know your availability group listener name. And then SQL Server will direct connections to the correct location, to the correct SQL Server. So in an availability group, the SQL Server can automatically fail over the entire group of databases from the current primary to one of the other secondary replicas. And this is super useful in the case of a server restart that's unexpected, or something else that you're not planning on happens and your primary replica isn't working correctly anymore. SQL Server detects that through the Windows failover clustering mechanism and through other means, and it will automatically, or it can be set up to automatically move the connection or listener name to point to a secondary replica that it makes available to you, and your application can just keep going. And usually the downtime for that is 10 or 15 seconds, and you're back up and running. I think this is helpful for a number of reasons. First of all, many of us, probably all of us, have worked in businesses where there wasn't a one-to-one relationship between an application and a database. There's usually, 2, 3, hopefully not more than that, but there are multiple databases that work together for an application to make it work. Well, an availability group can collect those databases together in a single collection, and then they move or fail over back and forth together. Helps keep your application up and running. Things like log shipping, which is great. It's a fantastic feature. It has a disadvantage here because there's no automatic failover. You have to manually do the work to get things up and running again. Mirroring is, one database at a time. Availability groups, you can do multiples. Also, unlike a SQL Server failover cluster, which requires shared storage, by default, it leaves you with a single point of failure. Availability groups allow for data movement between all of those nodes, and each node has its own independent storage. So because of this, you get redundant copies of your data. Now, in this particular picture, the availability group technology moves data, from that primary replica on the left over to any one of these secondary replicas. And this leads me to our next topic or idea about availability groups, which is disaster recovery. And I think availability groups make this easier for you as a data professional. So what we're looking at here is a depiction of a primary data center on your left and disaster recovery on the right-hand side. In your data center on the left, you'd have a primary and a secondary, so you'd have two computers, and there would be synchronous replication from that primary to the local the primary data center computer that's in your availability group. This allows you for that high availability, local high availability. Then you have a set of one, well, I said set. In the picture, it's a set, but you could have just one sitting out here at the disaster recovery location. But in this case, you have a set of computers in the disaster recovery location. And that's your means to staying up if something happens at your primary data center. So remember I said that it's a best practice to have an availability group listener. And in this case, what we're looking at is a multi-subnet availability group. So what is over in the disaster recovery location is going to be on a different subnet or segment of your network. The availability group listener will get, depending on, yeah, it will get 2 IPs associated, one with the local primary data center IP range, and one that fits the disaster recovery range. Now, here's where you need to think through and ask questions of your application people, though, because this could have serious ramifications for being able to fail over to your disaster recovery location in a timely manner. So there's a feature or setting, it's called not multi-subnet failover cluster. Sorry, I've lost my notes here. Multi-subnet failover true. So some applications support multi-subnet failover equals true, and some don't. So this is where you have to look at another setting called register all providers IP. If the applications do support multi-subnet failover equals true, then you should leave register all provider IPs set to on, which is the default. And what that does is it allows SQL Server to go out and talk to all the available IPs that are associated with the listener. And then it can make connection to whichever one it knows or figures out is the correct one. If it doesn't support this and you leave register all providers IP set to 1, then what will happen is you will get connections trying to connect to your DR center when that's not the primary, and they will time out. And you'll have this weird thing where someone's going to come to your desk. Well, maybe not today. I guess it depends on whether you're working remote. Today, they might message you in Teams or however your company communicates and say, yeah, Mr. Data Professional or Mrs. Data Professional or Miss Data Professional, we have a problem. Like half the clients said that they can't connect to the application. And the weird thing is everybody else seems fine. What's going on? And it'll, in the scenario I'm describing, it'll be because register all provider IPs is set to 1, but your application doesn't work with multi-subnet failover equals true. So you need to think through how that works for your application and set these things accordingly. So there is another kind of availability group called a distributed availability group. It's way more complex. Well, I think it's way more complex. It's certainly more complex than this, and we don't really, because of that, I don't have time to like go through what it looks like and how it works. But you can get this kind of high availability and disaster recovery with the DR. All you got to do is figure out the things that I just mentioned. It's not, those components aren't hard, but you just add one more computer to your Windows failover cluster, add it to the availability group, and it synchronizes, and you're done. If you're using something like, you have a single node and you want DR for that now, and you're not going to use this, now you have to figure out log chipping. If you have multiple databases, now you have to set up log chipping for multiple databases. There's no manual failover, so it's going to be painful to get up on the disaster recovery side. So I feel like this makes disaster recovery the simplest possibility. If you're lucky, and well, this might not feel lucky for people who are familiar with transactional replication. If you're lucky and all your tables have primary keys, first of all, you've won the lottery. Secondly, you could use transactional replication to have a warm standby. That's a pain in the butt to manage, and there's still no automatic failover. So I really feel like availability groups shine in terms of providing easiest disaster recovery. Another advantage that you're going to get out of this is you can use these secondaries to handle reporting queries. So that reporting group that's killing your primary because they want to send across these massive data warehousey type queries that consume tons of CPU and do lots of I/O, you can actually use this to direct those connections, or just tell them connect to a secondary and run your queries over there. Now, again, there are some gotchas there, so please don't just go out and make this change. But that is a possibility that you can do. You can also make this fairly seamless by using what's called read-only routing. So they don't even have to know the names of the other secondary computers. They just need to know your listener name. And then they make changes in their application that tells in the connection string for read-only routing. And you do a little bit of setup in the always on availability group properties. And when a connection is incoming with the proper connection string from the application, SQL Server will route that connection from your primary over to a secondary for the data to be processed and ran that way. So I've talked a while about availability groups. So I want to try to summarize a little bit in terms of the positives there. You get redundant copies of your SQL Server data. Yes, you're using twice the data. I understand that, but I feel like it's worth it for the redundancy. You have automatic failover for a group of databases. Relatively easy, as I talked about for disaster recovery. Something I didn't talk in great length about, you get or can get automatic page repair from a secondary. So if the primary realizes it has a corrupt page, it can actually repair itself using data from one of the secondaries. I mentioned readable secondaries using Direct Connect and read-only routing. One thing I didn't talk about is faster upgrade paths. So with an always on availability group, if you're on SQL Server 2016, I'm just going to pick something, and you have a project to get yourself up to SQL Server 2019, and you're on an availability group already, I'm going to oversimplify, but it's as simple as create your SQL Server 2019 node, you install SQL on it, you add it to the availability group. Please listen to this part. You set it so that it's manual failover to the SQL Server 2019 node. When you're ready to actually do the failover, and then you manually fail over to your SQL Server 2019 nodes, and now you're on SQL Server 2019. Voila. Now, please don't add one SQL Server 2019 to your AG. Add two, fail over to one of them, and then you can go through a process of dropping out the SQL Server 2016 nodes until you're just left with the proper amount of nodes for your SQL Server 2019 setup. Fast upgrade path right there. So the next thing I'm going to talk about in terms of SQL Server features in modern SQL Server that's going to make your life better is accelerated database recovery. So this is new in SQL Server 2019, and it gives you faster crash recovery. It is off by default, so this is something you have to turn on. This might change, but as of right now, accelerated database recovery is not on by default, based on the information I've seen recently. But what is it? So what this does is it uses something called the persisted version store, and it works a lot like read committed snapshot isolation. And if you don't know what that is, I'm sorry that was a bad analogy for you. It creates a record of versions of rows, and then uses those version records to do crash recovery. So if you are doing something like I have on the screen, where you have what I feel like are really horribly formatted emails, and you want to change it to first name dot last name at your company name. And somebody runs a script to do this. And in their test environment, because it always works on my machine, it works on their machine fast, and they were done in 2 minutes. I'm just going to make up some numbers. They give this to the DBA or to whomever, they run it, and 5 minutes has gone by and it's not finished yet. And people start wondering, what's happening? Why isn't it done? And somebody is trying to figure out whether they should kill this query or not, but they know that rollback is involved. But they also, either that person or someone else says, yeah, but guys, if you restart SQL Server, it does crash recovery for you. We should try that. So you restart SQL, and SQL Server comes up and you can connect to it, but no one can connect to the database at all now, which is, of course, even better, right? 10 minutes goes by and the database still is not up. I'm making up numbers, but a long time goes by, longer than expected, and you can't connect. And everybody's like, well, what's going on? Well, SQL Server is going through its traditional rollback process, where it's reading through the transaction log to figure out what to roll forward and what to undo. And that takes time. And if you're not managing, and on top of that, if you're not managing what's called the virtual log file sizes properly, this could be one reason why it's taking longer, in addition to all the work that you just put into the transaction log. With accelerated database recovery, it keeps versions of rows, and it uses those row versions to do just a quick, what I'll call switch out type recovery, rather than reading, sequentially through the transaction log. It sees all the row changes that you've made, and it has versions of those changes, and it just swaps out the old versions for what's in there and get your system back online a lot quicker. No need to wait around for the traditional rollback process using this accelerated database recovery. So you get faster crash recovery. How can you find this information for yourself? You say, Lee, this is great information, but I know there's more. And by the way, how did you find this information? Well, experience. I've worked with availability groups for a while now. I'm not, and so I'm familiar with availability groups. Most of these features I've worked with for a fair amount of time. So I knew about them from my own studying and from my own fiddling. But here are some links to some other places that help you find out information. There's a page there for what's new in SQL Server 2016, and it shows you 2016 and above. Previous versions link shows you everything prior to 2016. So you can dive into there and find out what Microsoft wants you to know about what's new. There's a great website that I like called MS SQL Tips. And in there, they have, when new versions of SQL Server come out, they have articles on what's new. So, and you can also see things like T-Sql Enhancement tips on MS SQL Tips.
Lee,
Places like...
terribly sorry. I'm going to have to cut this a little bit short. I have to use this session here in about a minute.
Okay.
I apologize. If anybody has any questions at all for him, we're going to have an open Q&A session. Lee, Chris is going to get you the info for that as well.
Okay.
So if anybody's got any questions at all, feel free, bring them for the session on Thursday. And otherwise, thank you very, very much. I'm terribly sorry to cut you off here.
That's okay.
But we'd love to have you back for a future session to finish this and add anything else you need.
Okay, it sounds good. Thank you all for having me.
Awesome. Thank you all, everybody. And hopefully we'll look forward to seeing you all on Thursday. Open Q&A session around anything with business continuity. Awesome. Thanks, everybody.